Well, hello there. Thanks for joining this session. So my name's DJ. I'm a developer advocate in the SAP Developer and Community Relations Organization here at SAP. And I'm joined today by, and I'm going to say this out loud, even though it might embarrass him, one of my all-time heroes, Karl Kessler, who I think it's fair to say, and I'm sure he won't beat me up for this, is pretty much about the same length of tooth, the same age in terms of sort of history with SAP as I am. And I'm hoping we're going to have a conversation about all things SAP R2, R3 and beyond, right? So Karl, welcome, and let us know, introduce yourself to us.
Thanks a lot, DJ, and Graham. Thanks a lot for having me in this call. That's fantastic. And I think you have still some additional years of service on your shoulders, I guess. We will figure this out. And I'm really happy and proud to be part of this conversation, looking into the history, but also have a clear view to what's coming. I think that's always important, looking back and looking forward.
That's a nice balance, actually. It's a really nice balance. Yeah, so just to remind folks, the year is 2022, which is the 50th anniversary of SAP, right? So a really, really nice year to be talking about this sort of thing. And I think one of the highlights over the past few weeks for me was to read the blog post that you wrote, Karl, on blogs.sap.com. I think it was called Evolution of ABAP, but it was ABAP and a lot more. Going right from pretty much the start, the early days of ABAP, and like you say, all the way into the future and embedded steampunk and so on. So let's talk about that stuff. Tell us about the blog post and why you wrote it and where you started.
Yeah, great question, DJ. And I think first of all, it was really this anniversary thing, 50 years of SAP, and we've had great parties and great communication, even a large book about the full history of SAP. And I felt that it's also important to look into the technical or technological history of SAP, because this is really the cornerstone. This is the foundation of all our business processes. And yes, of course, I mean, ABAP plays a major role in that context. So it's very natural to ask for the roots of ABAP. We even had a couple of, I may say, internal information sessions at SAP where we also shared experiences. There are still a couple of geeks out there that have more than 30 years of experience in SAP. And I found it always interesting to understand what is kind of the running concept behind such an infrastructure. There's a lot of phenomenons coming out there, and you see, for example, the syntax that's very prevalent. That means the syntax stays and gets augmented. But what about the infrastructure? What about the technological infrastructure? That changed heavily, dramatically, and we are again at a point in time where we now move to the cloud. Again, a tremendous transformation of the infrastructure. And the fun thing is always ABAP survived. Yeah, that means it stayed there. And that is what drove me, and where I thought it makes sense to share this little insight and to invite also the others to share their insights like you.
So yeah, I mean, the blog post really struck home with me, and it was wonderful to read. And I think you're right. I mean, you mentioned the word cornerstone, and ABAP for me is a cornerstone as well. And it has survived and changed and grown over the decades. And in your blog post, you start with R2, which of course is the predecessor of the architecture that's prevalent now, right? The R3. And one of the really interesting things is that, we look to the past from a historic perspective, enjoying the, what used to be. We're going to look to the future as well, but also what knowing about the past really does for me, and maybe it'll help other people as well who maybe are not so much aware of, where things came from, is why things are the way they are today, right? To understand, well, why is such and such a thing designed in this way, and why does that work that way? Why is this called? Why does this have this name or this restriction or this convention? And the conversations with with wonderful folks like you and other folks, other great, may I dare I say it, grey-haired folks in this community, it always goes back to where was the first time I wrote any ABAP, right? And I remember, and again, your blog post really brought the memories home. I remember I'd left university, I finished university, I'd studied Latin and Greek, right? So I was all ready for ABAP, right? Another language. But actually, when I joined a SAP customer, they were just installing SAP R2 4.1 on the mainframe, running IBM MBS, and the database system and the transaction monitor was IBM DB and DC, right? People may have heard of CICS as well, CICS, which is possibly maybe more well known than IBM IMS DC, but it was essentially the same thing, right? Actually, the reason I mentioned that is because maybe we'll get on to talking about where the dispatcher came from in R3, right? Anyway, so we were installing and running and maintaining SAP R2 4.1, 4.D, and everything was in assembler, right? Everything was in 370 assembler. That's where I got my, the SAP, the architecture that SAP provided was actually, and I'm not just saying this is not rose-tinted spectacles, but it was a beautiful thing. It was so well thought out. Love the abstract layers, and that's where I get my Q macro name from and everything. Anyway, the first ABAP I ever wrote was actually in some job control language, because ABAP appeared on the scene for us as a customer. This was in the mid to late 80s as a report writing language, as a 4GL, right? Fourth generation language, a little bit sort of low code, no code, dare I say it, right?
Absolutely.
So that's where, so I wrote ABAP as plain text in a sysin DD card, for those who remember those sorts of things, basically a punch card equivalent on the screen. And it was all about just, I'm going to say the word reading, but not explicitly actively reading, but passively reading segments from the database and sorting and summing and, accumulating values and putting subtotals. And that was it. That's what ABAP did when it first arrived on the scene. Is that your memory as well?
Yeah, I mean, for me, it was a little bit later when I joined in the early 90s at SAP. And there, R2 was basically the production environment. That means R2 was the system our customers like you used. And R2 was our mail system. R2 was our service system. R2 was our accounting system. Everything was R2. And for me, it was kind of, I was pushed back when I joined SAP. I thought they are still working on those 30 to 70 terminals. I was already used workstation screens, graphical workstations with Unix and all these variants of Unix, etc. Unfortunately, there was, I think it was a DEC Ultrix machine was still in the room. So I was relieved, kind of, okay, there's some place I could work for. And then I made a lot of comparison. Yeah, so I saw the 3270 world with IBM, and I had a couple of courses on ABAP 4. And first of all, it was hard to use the terminal, just the keyboard and no mouse and no pointer devices and no windows, basically. But my first experience where I thought, oh, this is really substantial is when I first worked with the R2 debugger, because I thought, oh, wow. So this is a 4GL environment, like you mentioned. It has also very good testing capabilities. That was super important. And the program model that was with the screens, with the DUN pros, how we call them, dynamic programs, if you will, that was fairly logical. A sequence of screens that are processed, and under certain conditions, you navigate to a different screen. And there was this concept of field control and field transport. That means if a field has an identical name on the screen and in the program, there's an automatic transport back and forth, and the usual error handling and kind of input validation stuff. And for me, then I really started to compare, okay, what could I do? What could I do on the R3 side of the house? R3 was not yet at the market. And you could really build very similar transactions. And for me, it was very easy to understand that the program model was, I would say, 90% identical between the R2 and the R3 world. So that it was a very natural way to build applications in R2 and then propagate, transport them to R3. Because in the early years of R3, there was the development environment was not yet ready. We didn't have tools. So the guys went to the R2 system, did the module pools and the screens and the transactions in the R2 development environment that you just talked about. And then they were transported to the Unix world and deployed on an R3 kernel to be started, to be executed. So it was really these two worlds coming very closely together.
I mean, you touched on one thing there that I really want to sort of bring to the fore for those those who have come to SAP in the more recent decades. You mentioned the DINPROs, the dynamic programs, which are essentially a screen-based programming paradigm objects, right? Some people may have heard of PBO and PAI, process before output and process after input. And we've got to remember that in the olden days, when we had these 3278 terminals, which I still love, and it's my favorite workstation environment. No mouse. Who needs a mouse, right? So green screen, keyboard. You could kill somebody with one of these keyboards. It was so made of metal, and unlike, for example, terminals in the Unix world, which are sort of character oriented. The IBM mainframe terminals were pretty much all, across the board screen oriented. So you would send, screens would be sent back and forth, one screen at a time. And therefore there was a natural sort of, a natural parallel between the programming model of a DINPRO, which represented a screen, but a DINPRO was a screen with logic, right? What needs to be done before the screen is displayed, and what needs to be done after the user has typed in some values into the fields and maybe pressed a PF key or typed in an OK code, and then sent the whole screen with the data back to the mainframe, right? So that's really the idea of where the DINPROs came from. But you mentioned something super special about the field controls, right? So you had this, and you explained this idea of you had the field transports. So if you had a field with the same name in the program and on the screen, the data was transferred to the screen, right, from the program to the screen. Now, isn't that familiar to people? Yes, of course it is. It's data binding in UI5. We have the concept of model view controller and the wonderful data binding, the two-way data binding that is possible with UI5. It's just the same concept. So while a lot of the stuff that we're talking about is super old, it also exists maybe in a different form and under a different name in the stuff that we use today, right?
Absolutely. And you just mentioned this screen control. And for me, coming from university, it was quite difficult to understand that in addition to the screen control, you also have this transaction control. That means, of course, I was exposed to relational database technology, also in my work student times and all that stuff. And then I learned at SAP, for the first time, if you have hundreds or thousands or even more users to serve, you need to operate in a transaction control environment. And you cannot allow that each and every user has its own application, word process, and blocks resources on the database like crazy. But rather, you need a transaction control, a transaction monitor, or the dispatcher in the R3 environment that really allocates the resources, allocates the work processes to the running sessions, to my program for a certain period of time. And then after this period of time, the connection is released, the resources are committed, the database commit is issued, so that transactions are short in nature. Of course, sometimes they need to span multiple screens, as we all know, and we have an enqueue mechanism to orchestrate that. But the essence is transactions are short, and you can only keep the transaction in a very short time frame. And for me, it's always interesting to see that now that we're also going into Kubernetes and these type of things that impose a lot of challenges on our infrastructure, it's still very important to manage resources. Of course, we have HANA, we have in-memory computing, all these great capabilities, but in essence, we are even consuming more resources and more end users and more transactions are running in parallel. And again, it's super important to manage containers that are aware of this transaction control in today's world. So that was valid in R2, it was valid in R3, it was valid in NetWeaver and Business Suite, it remains valid in the cloud world. So, and we have done a lot of investments in order to make sure that this runtime infrastructure is super efficient, super performant, and decades and really large resources have been invested, both machine-wise and person-wise, to optimize the runtime infrastructure. In that sense, just to bring it in one sentence, I would say SAP was always in memory. I mean, we have a great in-memory database like SAP HANA, but we had tons of data in memory, in the buffers, in the execution areas, etc. In the context shared memory that we have to run the parallel sessions in parallel user context, and extended memory it's called. That was essential to keep as much as possible data in the caches on the application server. I think that is a key ingredient of the ABAP runtime infrastructure.
Exactly, and if you think back, really, I mean, SAP, because of the nature of the software that they were selling and the way that the customers were wanting to use the software and the transactional nature, SAP was solving problems that other companies hadn't even got to yet, because of the scale and because of the spread of what R2 was as a platform and what R3 was as a platform. And again, just to go back, just to explain to the folks as well, what you were talking about there about the inability or the wanting to avoid locking up work processes with individual users' transactions. That was you mentioned the dispatcher. If you've ever looked on a running R3 system, for example, on a Unix system, or even Windows, you'll see a program called disp plus work, right? And when an R3 system starts up, a disp plus work process is started at the Unix level, the operating system level, and it says, on the first one, I'm going to be the dispatcher, and then it spawns a number of children, which are all the work processes that it then manages, and that's really it was almost like not in a bad way, but it was like a backward step going from the mainframe architecture, because we already had programs like KIX and IMSDC that did the role of the dispatcher. But just talking of mainframes, I mean, going back to what I mentioned before about 4GLs and report writing, one of the really future-facing ideas that I was exposed to as a assembler programmer in the R2 days, but also as an ABAP developer. It's like, ABAP, what's this? Was you wrote reports by saying get this segment, get SA or get KA, get KB, and so on. But actually, what was happening in the background, you weren't actually causing those segments to be read. You were saying it was an event-driven programming language. You were saying when a KA segment was surfaced, then do this. When a KB segment, the next level down segment was surfaced, do this, right? And this worked because actually what you were doing, you were just riding on the back of a horse, which was like a database read program, which ran in the background and spat up these different segments. It was absolutely amazing. But then ABAP, really came on in leaps and bounds. You mentioned hierarchical databases. You mentioned relational databases, right? And I remember we ran SAP R2 on IMS DB and DC, and we had, of course, DL1. It was a hierarchical database. And when DB2 came along, relational, we thought, what's this relational nonsense? That'll never take off, right? But of course, how wrong we were. But I mean, ABAP, grew from this simple but powerful and what everybody wanted, report writing language, through all the sort of iterations, tools started to be built, ABAP tools were built with ABAP, bootstrapping. And then, of course, sort of in the late 90s, just before the turn of the 21st century, OO came along, right? That is about then, right?
Yeah, that was, I mean, the advent of object orientation and ABAP objects, that was the official term that we used, or ABAP OO, but the official brand is ABAP objects. It was a major investment in many different aspects. I think first and foremost, I mean, it was a tremendous extension of the language. Yeah. And I think the designers have really done a terrific job in combining the traditional 4GL that you mentioned with those object-oriented concepts, not bringing all of the, say, nitty-gritty details that C++, etc. would offer, but rather I think that the major design goal was really to adapt Java as an object-oriented standard, so to speak, and bring it in a natural way to ABAP, combining object orientation and 4GL programming, so that it was very easy from within a method to loop over an internal table, or to use all the structuring capabilities that internal table offers also for the construction of objects, table of references, etc. And object orientation was, it was in the air, so to speak, because there was such a tremendous need to have sophisticated user interfaces. We had Microsoft Office coming along, Microsoft NT coming along, graphical user. We talked about 3270. So everybody wanted to see a drop-down box and a table control and a tree hierarchy and an edit control and very sophisticated interaction behavior. And object orientation, I would say without doubt, is the best way to express these graphical capabilities and the event notifications. It's very natural. Let's put it, it's not the only way to do it, but it's very natural. And we were heavily discussing, there were multiple directions also in BASIS at the time. What is the right way to offer object orientation? Do we need it at all? Yes, okay, that was sorted out. And then what kind of level, what kind of standardization do we want to take? And what are the tools? How do we interact with the graphical capabilities in Windows, with the OCX controls? And this really paved the way for a very broad adoption of object orientation, not in the sense that each and every table or structure is an object. That was never the intention. No. It was not the intention to convert the existing complex logic, business logic in SAP, to convert it in an OO only approach, but rather use object orientation where it adds a lot of value, where it makes sense, where it can be easily adapted. And you can combine the different language levels. That's also very important. And I think it was a great success. And one of my favorite projects in SAP was really this Enjoy SAP was the official term, where we had, all of a sudden, we had a lot of graphical user interfaces in accounting, in materials management. We had tab strips and we had table controls and all that stuff, HTML controls. All of a sudden, these gray screens or green screens, 3270, were graphical UIs. That is what I was always looking for in the beginning. And object orientation was somehow the key to get to this.
Well, I think you're right. And I think it's fair to say that, I think some people who know me know that I'm not the biggest fan of OO as a programming paradigm. However, I think that you hit the nail on the head in terms of, one of the major reasons why OO came to the ABAP language is to enable the building of these richer graphical modular controls. And of course, the beauty of OO in the modularity and the compartmentalization of code, that was clearly obvious as a massive advantage suddenly to us ABAP programmers, in R3, right? And I think it's even telling that, most people's first experience of ABAP objects was actually, the transaction SE24, yes, which had, the default view was a graphical view of what you were building. You didn't write, the definition and the implementation in ABAP. You designed it almost like, not quite, but almost like the screen, the screen painter way. You sort of, dabbed here, dabbed there, bit of this, bit of that. And all of a sudden you had this class that then you could instantiate and work with, right?
Absolutely. And you had full debugging support from the very beginning. That was always, I think that this is a really common theme across all of the stages. Debugging was always there. And it was also there at the very beginning. I remember an info session in the 90s where RFC was introduced. The guys were crying, when the first time an RFC logged onto a different system from one ABAP to another ABAP system, and then all of a sudden you stepped through the remote code.
Absolutely mind-blowing.
That was mind-blowing, absolutely. And we never adapted the RFC to an object standard for a couple of reasons. I think it's way more easy to handle values over the network rather than references. And in that sense, I think RFC remained and stayed there, very popular still until today, although we have now OData and all these higher order standards, that's clear. But for an efficient ABAP to ABAP communication, RFC was one of the duty standards. And it was, and we had even What I also liked in the very beginning was also the way how you could, for example, share sessions. Unfortunately, it has been removed. So we could run a joint ABAP session, and I share my screen with you without any PC Anywhere software, but rather simply because the dispatcher was able to connect to us both.
Yes.
And in that case, simply dubbed my screens to you. A perfect environment to do support and communication, even collaborative engineering. But I learned then at some point in time this functionality was removed due to, was it data protection reasons or whatever? So okay. I mean, the time is going on, and sometimes you have also limits. But this nature of all users being connected to the same infrastructure and be able to share information very quickly in a consistent fashion, that is one of the absolutely strengths, I would say.
That's such a powerful concept and a powerful existence. Yeah, I mean, what you mentioned about we never went far enough that we implemented an object-oriented layer over RFC. Thank goodness for that. I've got one word which explains why. Corba. Anybody remember Corba? No. Right. So it was the right thing to do not to introduce objects to RFC. But I'm at a fork. We're at the fork in the road here. I can't believe it. I've been timing this right. I've had instruction not to go beyond 4 hours in our conversation. No, just kidding. But I just want to talk very briefly about RFC and the direction my brain is going there. But then I want to talk about and ask you about the future with steampunk and beyond. But talking about RFC, I remember in the good old days, before any of the wonderful stuff that came along with SAP at Web, and I think a couple of years ago we had a great session with Bjorn and Thomas and co. About how the Internet Transaction Server was born and why what it did and why it was born, and it was absolutely that was like one of the event horizons that happened in my history of SAP, but not as big as I might be treading on thin ice here, but not as big as the introduction of the Internet Communication Manager attached to the dispatcher. All of a sudden, we had basically an HTTPD, an Apache-like, layered approach to a web server built into the architecture with the Internet Communication Framework, a layer of classes on top. Oh my goodness, that was still to me the most amazing thing to happen to the ABAP environment, right? Anyway, we won't go in that direction. What I do want to do though is go in the direction of where we went from ABAP objects and beyond. Maybe skipping through the whole Web Dimpro concept, but ending up with where we are now, with maybe from a philosophical point of view, a very interesting reduced instruction set, a RISC style ABAP in the context of steampunk, right?
Mm-hmm. Yeah, I think there's multiple very important aspects to what you just said. And let me just quickly go one step back to make the comparison between now and then. When R3 came to the market, we had to manage large workloads that are essentially coming from the mainframe, and all of a sudden a Unix system should run such a workload. And in the beginning, that was a challenge, no question. And we built a lot of optimizations, sometimes a little bit at the sake of the clarity. I would say we had very procedural program models, I would say. Mm-hmm. Very strong in processing logic. You mentioned the logical databases, nested selects and all that stuff.
Yeah.
Getting fields on the various levels. That is very process-oriented execution behavior, and which was highly optimized with caching, with cursor and statement caching, what have you. And but most of the program, let's be honest, most of the programs went the way like you have a large select loop inside, you have another select. So in a sense, some of the programmers were also avoiding join operations. Join was possible through dictionary, but join was not so popular. Let's be honest. And in a sense, ABAP had always to mediate between the different database platforms. Mm-hmm. Then all of a sudden, the SAP HANA arrived as our new in-memory technology, column-based, column-oriented, with very super large, fast execution power.
Yeah.
And all of a sudden, we could afford, technically, we could afford view processing in memory. So join had not to be computed always on disk in a relational database with very cost intensive optimizations, but rather you could do the join in a very efficient way in memory. And this led to this, what we call view building or core data services. That means, how about building up a hierarchy of SQL views, also inventing a complete, as you mentioned, a very tiny syntax first. Now it's quite complex again, but a very
tiny, beautiful.
Exactly, very from the design perspective, a very smart syntax that is a little bit apart from ABAP at first glance, but it's very properly integrated into the ABAP runtime environment, where you can express the logic of entities through associations with other entities, etc. View entities, etc. That means you can build really a semantical data model. Now, a data model was always present in R2, even in RFM, in the first one, in R1, if you will. R2, R3, a data model was always present. I remember the large wall paintings, etc.
From Aris, was it?
The data model, yeah, exactly, the entity relationship model, but it was on paper. Yeah. And now, for the first time with SAP, large ones, very large ones. And now, for the first time in SAP, it was in the system actively, visible in the system, navigatable in the system. You could start from an entity and through the associations navigate to all of the related entities without writing a single line of code, ABAP code. And that was accompanied with good tools, strong tools inside our Eclipse environment. And I think that was, for me, it was an eye-opener because it showed, yes, functionally wise, R3 and Business Suite was great, but it was always difficult to look into the data model behind, or you had to have good ABAP skills to understand what's happening. And now you had an additional layer to express how these relations are organized, what you could navigate in the tooling environment, in the runtime environment. You could very easily navigate from one entity to the other, following those associations. You could add UI annotations, similar like the DynPro, if you will. That means on a separate layer, you could then attach the graphical layout data or layout specification that drives the Fiori user interface. And for me, of us, this was really a big innovation, making ABAP a very strong innovation adopter. And let's be very honest, the last 6, 7, 8 years of ABAP has seen a tremendous amount of innovations to come across. Yes. Yeah, it's really hard to follow. That means a lot of new capabilities come on the language level, on the CDS level, in the infrastructure, and on the cloud capabilities, and now with Steampunk and embedded Steampunk. So, and I think that was really nurtured by this original idea to have views and expressions, view expressions, really covering the data model, the underlying data model of a complete S/4HANA system, and then certainly for you as a tool to build your own extension, etc. And I think that was, I would say, is one of the cornerstones in ABAP evolution, that we have now this flexibility and this freedom to express, and that you can very easily traverse and navigate all of those structures. And now we have enriched this with transactional capability, with the ABAP RESTful application programming model a lot more. Of course, we need now generators to build complex applications. That's clear. The RAP generator was a great invention in that direction. But all in all, I think to nail it down in one sentence, the data model is way more explicit compared to the previous versions, I would say.
I mean, not just explicit, but one of the things that I've suddenly realized, when you were expressing that, were you talking about, for example, the annotations in CDS? Yes. In terms of, sometimes I think it's fair to say that sometimes ABAP gets a bit of a bad rap because it's old, but it's been with us forever. But it's been with us forever, and it's still with us. And how many languages can you talk about in that context? But the thing is that when CDS came along, and when the annotations within CDS came along, we're now talking about, as if they're super new and exciting, declarative programming, declarative definitions, right. Infrastructure as code type thing. We would, so this is another example in my mind as an outsider as well as an assimilated employee now. But another example of super innovation and big thinking that arrives on the scene not just in time, but even before its time. And I think it's amazing.
Absolutely. And this kind of model-driven approach, model-driven was always a big topic. And it's not the first time WebDynPro was also model-driven, because we had these UI models and model view controller you mentioned before. So it's always a good idea to start with a model and not with a code. And no matter on what level you are, but many of the ideas that came across have been there also in the past to a certain extent. We talked about data binding, we talked about UI abstraction, even in the screens. There's a lot of data binding present in the classical DynPros. And in a sense, this is coming back on a higher level. That means a Fiori template is way more complex and way more powerful compared to a single screen. And has therefore it needs to be annotated to make it happen, to make it live, to make load all those capabilities that the Fiori template will deliver. But it has to be very naturally mapped to the underlying data structure and into the underlying data model, and has to inherit a lot of those capabilities like data types and relationships, because navigation is nothing else than basically a mirror of the underlying data model. If you have associations there, then you have navigation in the UI very naturally.
Exactly.
And this type of really taking the model not as a document that is being produced afterwards, but which is part of the development and engineering process, is actively embedded in the applications. This is a real big step forward, and probably we could have done something similar also in the past, but probably didn't have the comfort to run this in an efficient fashion, because memory was very expensive, and we could only keep the very most important data inside our caches. And now we can afford to have the whole database in memory, and I think that has really helped a great deal to pave the road for this new way, for this new model approach. And I think RAP goes into the same direction. It adds the transactional capabilities to this core model, also in a very consistent fashion over the multiple layers that we all know. And I'm quite confident that this will also accelerate and speed up the construction process of developing in ABAP. So ABAP is no longer say, okay, the small pieces here and there doing aggregations and doing sorting and searching. That is always important, but this is partially now being offered by the infrastructure, while we want to focus more on the complex data domain. And that is probably the most tricky part, to engineer the proper data model, which will then serve tons of different
variants. And we sort of see that is a super important topic, because you have subjects like SAP Graph and the Microsoft's equivalent as well, and we're talking about GraphQL as well. All these different ways of thinking about the data model and how to manage that and how to traverse that and so on. But I've got a little note from our moderator here to say, we haven't got long left. So, but I want to make sure that we don't finish this session without talking about, because we both mentioned the word steampunk, but some of the viewers might not grok what that is. So to finish off, can you tell us a little bit about what steampunk is, what forms it takes? You've mentioned RAP, which we know is you and I know is a critical part of what makes up why steampunk is so important. Tell us a bit about steampunk and the future.
Yeah, that's a great question, DJ. And I think we talked about RAP, so let's keep this aside. This is an essential part of steampunk. Basically, steampunk was the idea to bring the ABAP technology to business technology platform. So formal official name, SAP, BTP, ABAP environment. ABAP developers should be able to run their code in the cloud. Perfect. Yeah. And now for cloud, of course, you get a system provisioned easily, and you can onboard users, and you don't need to run the lifecycle process. So that's all being taken care by SAP. And you have a hyperscaler on which you can run your workloads. that's all relatively easy to understand. What is probably a little bit more difficult, especially for the classical ABAP developers, is you have to use a little bit more discipline when doing development. And the traditional ABAP developer out there, even in R2, they could use whatever was part of the dictionary. They could call whatever function module was contained in function library. They could even modify code in R2 and in R3. That was all possible. So you had the source code, you could change whatever you liked. And of course, we know nobody's as naive that he will do all of those changes. I know from many partners and customers that they say, yes, of course, we have selected a lot of tables. We never modified or manipulated tables from SAP, but we have read data out of it. Agreed. Sure that they would survive probably. And now we want to remove this uncertainty and want to introduce core data services that are stable, that you can call without having nightmare.
Trustworthy.
And also local APIs. That is the idea of embedded steampunk. That means calling APIs that you can rely on and which survive the next upgrade, where we have a proper lifecycle process behind, where we can manage the upgrade process at large scale because the interface level is stable. That is one of the ground or foundational ideas of steampunk, as well as embedded steampunk. As embedded steampunk just adds the application level to it. So while steampunk was basis, embedded adds also the application perspective. And so business objects can also be addressed through a local API, through RAP facades, how we call them. But the essential promise is you get a set of entities, you get a set of core data services and APIs, function modules, classes, RAP facades, where you can build your extension on. And we promise that this remains unchanged with the next quarterly version. Each quarterly version, your application will survive. And remember all of the adaptation efforts that you had with SPDD and SPAU. I don't remember. Without change. Has that ever happened over the last 20 years in ABAP or 30 years even in ABAP? No. So in the cloud, you can rely on this stable API layer. And that's the big thing. RAP could also be run in on-premise, no problem. It's agnostic. You can use it everywhere. Even CDS can be used. But the essential thing is we have now a scope of objects. So we call them the released objects. And they're really nicely transparent also inside the tools that you can rely on and where you are safe. And they are checked by the compiler and both by the runtime system. So if you have any violation, ABAP will detect what you have done wrong. So no chance to escape. And I think that's the essence. So of course we had to reduce the language, get rid of the open data set and these type of things. Or since we don't support GUI, no matter what, call screen is not allowed. And I think we need to go for modern user interface experience. That's for sure. That means, but this is learned quite fast, I guess. The important thing is you have a set of stable APIs instead of stable CDS, which you also can treat as an API if you will. And you must use them in order to build a cloud compliant application, even if you start in on-prem or even if you start in private cloud, which is based on the on-prem code line. So if you follow those guidelines, and we're building a little guide, extensibility guide that helps you that teaches you to run this exercise, then you're on the safe side. You can then decide on your own when is the time ripe to transfer to public cloud.
Yeah. I mean, absolutely. I think the past and the present are super interesting, but the future is just as interesting and just as innovative as well. I mean, I think it's easy to forget how much innovation has been happening over the decades, right? And you just, as an example there, you've just shown or described the innovation that's been happening over the past 5 years, right? And I think we'll be, God willing, you and I may be talking about ABAP in another 10 years' time. So
let's see who survives here. ABAP will survive.
No, exactly. So, Carl, we've got to wrap it up there. So, thank you so much for such great insights. If you've not read Carl's blog post, we'll put a link in the description to the blog post and also to the resources that Carl mentioned as well. Thanks so much for joining. Let us know if you've got any questions. And yeah, we'll see you on the other side. Thanks, Carl.
Thanks, DJ.